Hello everyone, today I will talk about the Elasticsearch for Big Trajectory Data Index. My presentation has 4 segments: dataset overview, introduction of temporal query, comparison of the Elasticsearch and the Phoenix, evaluation of Elasticsearch. First, I will introduce my datasets. The first dataset is 2 GB trajectory data. It records the GPS point and other information of a certain taxi. It has 7 attributes: exact time of this record, taxi ID, latitude, longitude, road number of current position, and current speed, and whether this taxi has passengers. In this project, we mainly focused on the geographic coordinates, time, and the taxi ID in this dataset. I use this dataset for the comparison of Elasticsearch and the Phoenix. The second dataset is 52 GB trajectory data. It has 4 attributes: taxi ID, start time, end time, and the path this taxi has passed through during this period. This dataset was used for the evaluation of Elasticsearch in real distributed system. Next, I will introduce the temporal query. Temporal query was always used in big trajectory data analytics. There are ID temporal query and spatial temporal query. For ID temporal query, for example, find the trajectories whose taxi ID was 6868 during 4 p.m. to 6 p.m. For spatial temporal query, for example, given the geographic coordinates of a railway station, find all trajectories passing through this railway station during 4 p.m. to 6 p.m. My goal for this project is to find an efficient tool to deal with temporal query for big trajectory data. The current way for temporal query is to use the Microsoft Azure Bigtable. For ID temporal query, it will create a table for every taxi ID and use Azure partition key plus row key as indexing. Given ID temporal query, first, according to the ID, we find the table. Then in this table, we could retrieve the desired records by partition key and row key. For example, GPS point at 10:35 June 11th, 2017, the partition key is the date and the row key is the whole exact time. For spatial temporal query, it will first divide the complete area into several small regions and create a table for every region. Same as ID temporal query, partition key is the date, but the row key is the combination of exact time and the tax ID. By this way, it could answer the temporal query quickly, but the data was stored redundantly and is hard to update and maintain the indexing tables. The solution for this problem is to build secondary index. But traditional big data analytics tools like Hadoop, HBase, or something else didn't support secondary index. Therefore, I try to use Elasticsearch and HBase plus Phoenix to solve this problem. Next, I will talk about the comparison of Elasticsearch and Phoenix. This is the sample run of spatial temporal query in Phoenix. It took 41 seconds to answer the query. And this is the sample run of ID temporal query in Elasticsearch. It took 2 milliseconds to answer the query. In this chart, we can see Elasticsearch and Phoenix took nearly the same time to import the 2 GB data. But for disk usage, as you can see, the blue one is Elasticsearch and the orange one is Phoenix. The Elasticsearch took less disk space. And for the deployment of these two tools, as you can see, in my personal experience, The deployment of Phoenix was really a torture. You have to deploy both Hadoop HBase and Phoenix, and find the most stable and compatible versions of these three different tools. And there are all kinds of weird bugs during the deployment. But for Elasticsearch, it's really easy. It's kind of like took me 3 hours to deploy both Elasticsearch, Logstash, and Kibana. This chart is the comparison of performance of Elasticsearch and Phoenix for temporal query. The Elasticsearch used millisecond as metrics, while Phoenix uses second, even 10 seconds as metric. You can see Elasticsearch totally beats the Phoenix, either in the spatial temporal query or ID temporal query. So since Elasticsearch has such a good performance, I decided to further evaluate the performance of Elasticsearch. Since the previous tests are in fake distributed systems with relatively small data, this time I use 52 GB data in real distributed system. For this system, CPU was 8 core, RAM was 32G, JVM heap was 16G, and it has 3 nodes. I used the Rally, which was the official tool of Elasticsearch, to benchmark the performance. This table shows the resource cost of Elasticsearch. As you can see, the heap used for segments and the heap used for doc values are pretty small. This table shows the performance of indexing data. Basically, Elasticsearch could index 2,000 documents per second. This table shows the detailed information of the performance of Elasticsearch dealing with small time range or large time range temporal query. The small time range was the left table. It was from like 2017 December 23rd, and the large time range was the right table. The bbox query is just a special query, but it's called bbox query in Rally. Given the geographic coordinate of a bounding box, find the trajectories within this bounding box. The left table this table shows the detailed information of the performance of Elasticsearch dealing with small or large bounding box query. The left is small bounding box and the right is a large bounding box. The small bounding box is like 55 times 8 kilometers, and the large bounding box is like 116 times 5 kilometers. And the bbox temporal query is the spatial temporal query. This table showed the detailed information of performance about Elasticsearch in spatial temporal query. As you can see, the unit for the performance of Elasticsearch is millisecond. It's really fast and efficient. Since the time and the computation resource limited, so far I could only evaluate the performance of Elasticsearch in real distributed system. Hopefully, I could test the Phoenix in the future and compare them to see whether Elasticsearch could beat the Phoenix again in real distributed system with real big trajectory data. Thanks very much.